Welcome students. In this video, we will be discussing about how to display linked list. So in the previous video, if you see, we have discussed about like the idea of linked list. Then we discussed about what is linked list. Then also few syntaxes that I have listed in the previous video. And now we will be taking a simple linked list and we will be discussing how to display all the data part of the linked list. Okay, fine. So for example, we will take a linked list. Coming to linked list, already we have seen how to create a linked list. For example, we have to be creating a pointer. Okay, we have to be creating a pointer and let the name of the pointer be first. Okay, the name of the pointer, let it be first. Okay, you create this pointer in the stack memory, and then you create a node in the heap memory, and the node will have a data part and also it will be having a pointer to next node. Coming to the data part, you will be storing some data, and then the next procedure is you have to take the address of the first node and you have to store it in the pointer that we created in the stack memory. Then if you want to insert one more element, then create one more node, insert element, take the address of the node, place it in the pointer to next node of the first node. So similarly, we will be adding further node, and the very last node, if you see, to determine or to identify or to show that some node is the last node. Last node means it will not be having there is no need to store the address of any other node. So instead of that pointer to next node, instead of having it as empty, we'll be storing a keyword called null. So if the keyword null is found, then you can say that this particular node is a last node of the entire linked list that we have taken. Right? Fine. So now let us check how to display a linked list. Fine. So now coming here, right. So first of all, what we need to do is we should be starting with the very first element. We should be starting with the very first element. So the first node, okay, first node. So coming to the very first node, the first node can be accessed with the help of the pointer first. Okay, because this pointer first is actually storing the address of the very first node. So if you want to access something, so now this pointer called as first is actually referring to the first node. But in the process of printing all the element of the node, you should not be using or you should not affect this pointer, because if there is any change in the value of the pointer first, then the entire linked list will be lost. Because having the address of the very first node is very important thing for a linked list. If the address of the very first node is lost, then absolutely the entire linked list is also said to be lost. So let us not include this first in the game. Let us create one more pointer. Okay, let us create one more pointer. For example, we'll be creating one more pointer, and the name of the pointer, let us take it as so the name of the pointer, let us take it as temp. Okay, so let us take it as temp. The name of this new pointer that we have taken is temp. And how to make this pointer refer to first node? How first pointer referring to the first node? Taking the address of the node and storing it. That is the only way of referring to a node or pointing to a node. So if this pointer called as temp, if this is also storing the address of the first node, then this pointer also will be pointing to the first node. So how to take the address of the first node and store it here? The address of the first node is available only in the pointer first. So what you do is you can take the value of first and you can assign it to temp. Okay, for example, I can just show you. For example, first of all, you need to take a pointer called as temp. What is going to be the type of pointer? See, whenever you are going to store the address of an integer variable, then the pointer that you take can be a integer pointer. If you're going to store the address of a float pointer, if you're going to store the address of a float variable, then the pointer can be float type. Similarly, now what you're going to do, you are going to store the address of a node. So whatever is the type of the node will have to be the type of the pointer also. So what is a type of node? Already in the previous videos we have discussed that. Okay, we have taken a node structure, for example, struct node. We were defining a node structure. So the type of the node is actually struct node. This is the name that we give. If we This is a name that we are going to provide. It is not, node is not the constant one. So when we define a structure, whatever name that we are providing there to the structure, that is going to be the type of the node. Okay, so struct node is the type of the node. So what should be the type of this pointer? Struct node pointer. So declare a pointer temp. So you have taken a struct node pointer called as temp, and to this variable you should be taking the address of the first node and you have to be assigning it here. So the address of the first node is the value of the pointer first. So take the value of first and assign it to temp. That's it. This is a simple statement. So whatever value is there in the pointer first will now be assigned to the pointer temp. So now this 200 will be automatically transferred here to the temp pointer. So now 200 will be here. Okay, fine. Now this pointer called as temp will also start start pointing to the first node. So two pointers are now referring to the first node. One is first, the other one is temp. First we should not touch it, we should not be disturbing it. So we can use temp for the traversing purpose. Traversal, in the sense, traversal is like moving from one node to another node. The complete visiting of every node is what called as traversal. This concept of traversal is actually very much important in almost all the data structure, because traversal is what giving you the ability to visit each and every element of a particular data structure, right? So now after creating one more pointer and making that pointer pointing towards the first node, after making it possible, the next thing that we should do is that we should start our movement. That you should move from first node to second node, then from second node to third node, and from third node to fourth node. That is what the entire traversal is all about. But what we are going to do is that we're not going to do that much, right? Actually, what we are going to do is we will be actually moving from only one node to another. We are going to write a piece of code which will move the pointer from first node to second node. That's the very first process that we are going to do. Now temp is actually referring to first node. I want temp to refer second node. How is it possible? How temp is referring to this node? Because this pointer is storing the address of the first node. So this pointer is referring to first node. How to make it refer to second node? This already we have discussed about discussed in the previous video. That is, I have shown you few syntaxes. So when you want the temp pointer to refer to second node, you should take the address of the second node and you should store it here. So where is the address of the second node available? Address of the second node is available in the pointer to next node of the first node. So how to access this particular pointer to next node? Yes, in the previous video, in the node structure, we have given the first part the name data and the second part the name next, right? So temp of next, whatever is temp of next, whatever is there in temp of next have to be again assigned to temp pointer. Then only 230 will be stored in temp, and automatically temp will start referring to the second node. This is how you move from one node to another. Already I have told you the same syntax. Like when you provide temp of next, what you are accessing? You are accessing this address 230, and that address now I'm going to store it back in the same pointer temp. So temp is equal to temp of next. I think in the previous videos I have shown you like p equal to p of next. So that is a method of moving a pointer from from the present node to the next node. So temp equal to temp of next is a statement which will move the pointer from the present node to the next node. Okay. So you have moved the pointer from first node to second node. So one possible movement has been done. But only one movement is not enough to traverse all the node, and also it is not enough to display, because you have to move to every node to display the data part. So how this is possible? One movement I have written the code. If the same thing has to be done for 2 or 3 times or more number of times, or like n number of times, that we do not know the value of n itself. So if you want to repeat the same process again and again, there comes a concept of looping. And here we will be using a loop called as while. You can ask me, why can't I use for loop? Why do I want to go for while? Because you have to be using while loop in a scenario where you do not know how many times this process is going to take place. When you do not know when some process how many times it is going to take place, then I will be preferring you to go with while. Suppose if you know the finite number of steps, if you know the finite number of steps that you are going to carry out, then you can probably choose for loop. But here, the idea of linked list is itself like we do not know the size in the runtime. When we do not know the size in the runtime, then we actually step into linked list. So when you do not know the size of the linked list, then actually we have to be going with while, because we do not know how much time this movement is going to take place. But up to when so first of all, let me just surround it with a loop. Okay, so I'm just surrounding it with a while loop. Right. Now coming to the condition, so you keep on moving from one node to, see what will happen here. Initially temp equal to temp of next will move the pointer, instead of referring to first node, it will start referring to second node. Again what will happen, this while loop will work. So again I will execute the same line. So now temp is referring to this node. So again what will happen, when again temp equal to temp of next is executed, 320 will be assigned to temp, and temp will start referring to third node. When again the same statement is executed, then 400 will be taken and stored in temp, so that temp will start referring to the last node, and this keeps on going. So this process keeps on going. So until when this movement process have to take place? Until, see, temp equal to temp of next, automatically 230 will be stored. Then again temp equal to temp of next, 320 will be stored in temp. Then again temp equal to temp of next, 400 will be stored in the pointer temp. Again once you do temp equal to temp of next, what is temp of next? Null. So temp of null will be taken and it will be stored in temp. So once your temp is storing with null keyword, then it is actually the end of the linked list. It points to the end of the linked list. Suppose if your temp is not having null keyword, then automatically what will happen? Automatically your movement process can happen, because still you have not reached the end position. Okay, so the condition that I am going to write is, if the temp pointer, if it is not equal to the null keyword, then this movement process can keep on going. But while you move, before you move from first node to second node, you have to print. You're going to, because the entire concept is like display a linked list. So before moving from first node to second node, print the data part of the node and then move to second node. Okay, so a printf. So what we will be doing? We'll be doing %d space. How to access the data part? You can use the pointer temp, arrow mark, and then the member data. So after printing the data part, then what you're doing, you're moving from first node to second node. Again, is the temp is not equal to null? Yes, because 230 only will be stored. So temp will be not equal to null. You enter, and now temp of data, it will be printing 34, and again temp equal to temp of next. So 320 will be taken, and it will be stored inside temp. So this keeps on going until you reach null. So this is a procedure how you should be displaying a linked list. So what should happen? First of all, how is a linked list actually? You start with a pointer, first pointer, which is created in stack memory. Then every node will be created in the heap memory, and the address of the first node you place it in the first pointer created in the stack memory. Then for the subsequent nodes, the address you are placing it in the immediate previous nodes pointer to next node, you are storing the respective address. If you want to start your displaying process, first of all, instead of using the first pointer, take the help of temp. One more pointer you take and make that pointer points to the first node. And then what you do, the next thing is for the subsequent you will be storing the okay, fine. So the first, so you make one more pointer which is also going to point first node. Now with the help of temp, first of all print temp of data, and then you move on to the next pointer with the help of temp equal to temp of next. After reaching next node, again your loop will run. Temp is not equal to null. So again you will print temp of data 34 and temp equal to temp of next will move temp here. Printing data 45, then take the address 400 and store it in temp. So temp equal to temp of next. So automatically temp will be moving to next one. So 54 printed and one more time temp equal to temp of next is executed. Automatically temp will be stored with null. So again now you check temp not equal to null, your condition gets false and the entire process stopped. So you have traversed over all the node and also you have printed. The only purpose of traversal is not only to print. You could have done any process. While you traverse, instead of printing the data, you could have added all the data together. Right? You could have added all the data together. You could have searched for some data. So you could have done any process, but the traversal is very important. The traversal is only not for displaying, it is for lot many process. But here this is like how to display a linked list. So that is why we have printed the data and we are showing it. Right? So next video we will be discussing the implementation of how to display a linked list. Before we will in the implementation part we will look into how to create a linked list with the knowledge that you have. So first of all, we will be primarily creating a linked list. Then after we finish creating a linked list, then we will go for displaying a linked list. So these are the two things that we are going to do in the next video iteratively. Okay. So in the subsequent video, we will also have the recursive implementation of how to display or how to create a linked list. Followed by that, we will be having a complete analysis of if I need to create a linked list, what is going to be the time complexity, what is going to be the space complexity, and if we want to display it, what is going to be time complexity, space complexity, then what is the difference between the iterative approach and the recursive approach. So all this analysis will be done in the subsequent part. Right? So thank you, students.